In this lesson, we're going to go ahead and do some examples where we solve rational equations. So we're going to follow the procedure that we outlined in the introductory video, and we're going to make sure we check our solutions at the end of the day to see if we have anything extraneous. So to start off, we're going to go ahead and take a look at our example here, and we're going to start off by doing our step one, which is basically determining the least common denominator. Now, in order to do this, we would have to make sure both our numerators and denominators are in factored form, which they are, and then that would allow us to determine the least common denominator. So from our first rational expression, the denominator is x. So in our least common denominator, we have to be big enough that every factor is accounted for. So from that first rational expression, we need that x in our least common denominator. And then from our second rational expression, the denominator has a factor of x plus 1, so we need that as well. And then we have no more denominators besides 1, which we don't need to write. And so at the end of the day, our LCD is x times x plus 1. So then what we do is we rewrite our equation where we multiply every term by that x times x plus 1. So x times x plus 1 times our first rational expression, which is 1 over x. And if you want, you can make that one big fraction, plus x times x plus 1 times 2 over x plus 1. And then that'll equal x times x plus 1 times 1. So you can see that we multiplied every expression by x times x plus 1. And then in your step 3, so this is kind of a step 2 and 3 together, we would cancel any common factors that we have. So I'm going to go ahead and show that canceling. So x and x are common, x plus 1 and x plus 1 are common. So those are the only common factors that we have. So then what we need to do is we need to do our step 4 where we simplify. So this includes multiplying our expressions back together, combining like terms, distributing if we have that, all those steps to simplify so that we're able to do our next step, which is solve for x. So x plus 1 times 1 is x plus 1 plus 2 times x, so that's just 2x, equals x times x plus 1, distribute that, you'll get x squared plus x, and then all of that was multiplied by 1, but that doesn't change anything. So then go ahead and combine any like terms that you have. So we'd have 3x plus 1 on the left hand side, and then x squared plus x on the right hand side. And then what I would do is I'd go ahead and move everything to one side. I'm going to move to the right hand side since that's where my highest power term is. So I'm going to subtract off 3x and subtract off 1 from both sides. So subtract off 3x and subtract off 1 from that right hand side. And then we can see that what we're left with on the right hand side is, well, on the left hand side is 0. And then on the right hand side we have a quadratic, so x squared minus 2x minus 1. And then what I would normally do if I have a quadratic is I try to factor it, but in this case we're not going to be able to factor that quadratic down. So instead, in order to do our step 5, which involves solving for x, what we need to do is just use the quadratic formula. And so we know our a value, or a coefficient, is 1, our b coefficient is -2, and our c coefficient is -1 in our quadratic. And so then now we can use the quadratic formula, which says the opposite of b plus or minus the square root of b squared, which is 4, minus 4ac all over 2 times a. And then just continue to simplify that expression down. You have 4, and then what I do is I go ahead and just take all of these and multiply them together. Negative 4 times 1 times negative 1 is going to be positive 4 all over 2. But that's just 2 plus or minus the square root of 8 over 2. And then continue to simplify. 8 has a perfect square factor. It has the factor 4, so that's a perfect square, times the factor 2 all over 2. But then that allows us to take that square root of 4 where a whole 2 comes out, all over 2. And then now we can see that this expression can simplify because we can divide each of these terms by 2. So 2 divided by 2 is 1, and 2 square root of 2 divided by 2 is square root of 2. So at the end of the day, my solutions are 1 plus square root of 2 and 1 minus square root of 2. And if we go to do our last step, which is check these, when we look back at our denominators, neither of these answers would make our denominator 0, so we don't have to worry about that. And so at the end of the day, we will see that these both check out, so these are both our solutions. So 1 plus square root of 2 and 1 minus square root of 2.